Hi everybody. Over the past few episodes I've been using a command called Chmod. For those that already know what Chmod is and the actual values that are provided to it, what the decimal notation is, you might want to skip this video. This is more of a informational video for those that aren't so experienced with file permissions under Linux and what these values mean and what they're for and why it's dangerous to set things to values like 777, which I've mentioned a few times now already. So if you've already gone down this track, feel free to skip this video. If you don't understand what these numerical values are, please listen, because these values can be critical to the security of your system, not just a server, but even your home computer. Now, to explain what they are, we need to jump into a console for a second. So what we'll do is we'll switch back to the terminal. This is still connected to our virtual machine we've been building. And I'm currently sitting inside the public HTML directory for the WordPress install we just did. What I'm going to do is list the files as a list, as in long mode. By specifying -L, we're actually going to see the permission, the mode bits as well for each file. Now, this might look confusing to you, but there's a few things that need to be shown, and it gets pretty simple really once you understand what this is. Now, for a file, index.php, that's just a plain file. You can see we just have on this very first entry just a hyphen. That indicates this is a standard file. But on something like a directory, you'll see this very first entry is a D for directory. So this very first column is just telling us what type of file this is. Under Linux, everything's a file. Directories, while under Windows, we always call them directories or folders or something. Under Linux, they're still files as far as the file system's concerned. They're just a different type of file. In this case, a directory. If it's got an S on there, for example, it's a socket, which is still a file on the disk. It may be a special type of file, but it is a file. So this actually has nothing to do with permissions directly. The next values all do. Now, there's actually 3 sets of values here. What I'm going to do is, just for example purposes, I'm going to do what I tell everyone not to do, is firstly, I'll create a file called test. And if we list all the files, we'll see that there, just here, test. And what I'm now going to do is I'm going to do the nasty and go chmod, 777 on the test file, and we'll list them again. You can see now the color of that changed because the system has realized this is an executable file now, and it's basically highlighting that to show that to us. By default, executables are normally green, but because of the LS colors we applied in the last tutorial, we're seeing that as orange. But anyway, over here on the left, you'll note our permissions have all changed. We now have them all turned on. This is 3 groupings. See, it's a repeating pattern. RWX, RWX, RWX. Each group of 3 applies to a different thing. In this instance, the first group of 3 applies to the user. This column here is the user that owns the file. So this is saying the user, in this case root, owns this file because we created this file as the root user. So the root user is allowed to read, write, and run the file as if it's a program. The next 3, RWX again, represents this column here, the group. This file belongs to the group root, again, because we created it as the group root. And this says anybody else that's in the group root is allowed to read, write, and run this file as if it's a program. The final 3 doesn't have a column. That's because this is for everybody. So any user on the system. And again, it's saying that anybody can read, write, or run this script or this program, or this file as if it's a program. Now, this is not a program. This is just an empty file we created. But it's going to let us try to run this because it's got the X bit turned on. Now, for directories, it's a bit different. So what I'm going to do is first remove this test file. I'm going to become the YT user. because we need to do that to explain this and to demonstrate this, because the root user is able to do everything no matter what the permissions are. We want to be restricted in what we're doing here for example's sake. So we're already in, sorry, I cancelled that. We're already in the home directory for the user. We'll go into the public HTML directory and you'll see there's our listing again. You'll note the syntax highlighting, the file highlighting's gone back to defaults because of the way I changed user, but we don't need to worry about that at this point. What I'm going to do now is I'm going to make a directory and we'll just call it test. So we'll list them again. And you can see now we have the directory test. It's owned by YT because I am now the YT user. And its permissions have been set to a default set of the octal notation will be 755. And I'll explain that in a minute. But what I'm first going to do is, because this is a directory, I'm going to go chmod -x. So I'm going to turn the execute bit off on the permissions for everyone. So if we list them again, you can now see X is gone off this. Now, for directories, that doesn't mean you can run the directory, because you can't run a directory. X actually means on directories if you can enter it and list its contents. So if I now try and cd into test, permission denied, because we don't have the execute bit set. I can't even list the contents of it. Oh, sorry, it is going to let me try to. I can't change into it. No, sorry. Read will let me list the contents. We have to take the read bit off as well. X lets me change into it. Read lets me read the contents of the directory, not the contents of the files, but the actual list of files. So if we remove the read access from the directory and try and list it, now we get permission denied on that too. So execute works differently on directories, and that's the point I'm trying to make here. So we'll remove that directory again. And what I'm now going to do is create a temporary file, again, called test. So this is now a file again. And I'm going to do what everyone says not to. I'm going to, again, change this to 777. And again, we'll see all of these bits are turned on. Now, I've done that so that I can show what they are a bit easier. Actually, what I'll do is I'll list the test file only, just to remove that from the grouping. So now what I'm going to do is we'll jump across to Chrome, and we're going to take advantage of a feature Google has just because it's easy, everyone has access to this. We're going to use Google to do conversions of decimal to binary. When people say to change a file ownership to 777, you need to understand first that that's not the number 777. It's a grouping of 3 numbers, 7 and a 7 and a 7. The first 7, sorry, I'll go back to the terminal actually to show this. So we had the 777. The first 7 references the first 3 permission bits for the user. The second one, the second number in this order, references the next 3 permission bits, which are for the group. And the final one, the last 7, references the last 3 permission bits for everyone else. So it's actually 3 numbers, not one number of 777. So back into the browser, what we're going to do now is we're going to convert the number 7 to binary. Now, if you don't understand binary notation, this is sort of a standard way to notate binary. Prefixing with 0b to say this is a binary number so that when you see this number, you don't read it accidentally as the number 111. It's actually the binary number 111. Now, just like in base 10, where you have your ones, tens, hundreds, thousands, etc., you've got your columns, right? In binary, we have columns, instead of ones, tens, we have ones, twos, and fours. And then if you want to continue, it would be then 8s, 16s, 32s, 64s, and so on. It goes up in base 2, in powers of 2. That's because, as the name suggests, bi in binary meaning 2. Just like in decimal, the DEC for dec means 10. So in binary, it's base 2. Binary also works just like decimal, right to left. So this is our lowest denominator. And with computers, we always count the column, this first column, as column 0. So this is bit 0, because these are ones and zeros, so they're called bits. So this is bit 0, bit 1, bit 2 for their position, not their value. So we can see here the 7 equals 111. So this being 1s, this being 2s, and this being 4s, 4 plus 2 plus 1 equals 7. So we add them up to get the value 7. So some of this might be starting to ring a little bit clearer now as far as the way file permissions work. Now, each of these bits is like a switch, like a light switch. It can be a 1 or a 0. And they each represent something different on the file permission. The first one here represents read. The second one, obviously I'm working left to right here, the second one represents write, and the third one represents execute. So an executable file must have that one set to 1, so column 0 set to 1. A writable file must have column 2 set to 1, column 1 set to 1, and a readable file must have column 2 set to 1. So there's all three switches in the on position. So when someone says to say set the file to say 655, we can go 6 to binary, you'll see this here is turned off. That's the execute bit. So this file would then be read write, but not executable, not runnable as a program. Or if it's a directory, not enterable. The 5, say if it's 655, this is what the 5 would be. So this would be executable, not writable, so you couldn't write to the file, but you can read the file. So you could, if it was a program, you could run it and you could read it. If it was a directory, we could enter it and we could list its contents, but we couldn't create files because writable is turned off. So to demonstrate this, we'll jump back across to the terminal and we'll do the base values on this test file. So if we go Chmod for change mode, and we'll say 111. So 3 ones, not the number 111. Remember, they're 3 separate numbers on the test file. And then we'll list the test file again. You'll now see only the execute bits are turned on. If we wanted to turn on only the execute bits for the user and the group, we would need to say 110. So you can now see we've turned off the execute bit for everyone else, but the user and the group still have execute. So we can do the same thing with each of the values. We can go 222. We list that. You can now see that we've enabled only write for everybody. And then if we go Chmod 444, we've turned on the read bits and turned off the write bits. So to get a combination, we just make combinations of the numbers. We add them up. So if you wanted read and write, we could go 2 plus 4 is 6. There you go. We now have read write. Conversely, if we wanted to make them all just executable, like we did before, 111. Or if we want to make them readable and executable, it would be read plus execute. So 1 plus 4. So that'd be 5s. So read and execute. Now, this takes a little bit of getting used to, and the more you do it, the easier it gets. It starts to become sort of natural to see these numbers, and you sort of get used to the pattern of what you should be using for what you're doing. You can also set user masks. The user mask allows you to mask off some of these bits so they never can get turned on when a file is created. And there's a command to set the user mask called umask. We're not going to play with that now, but that's something you might want to look into. There's a way to say, okay, never ever allow the execute bit to be turned on, for example, when a new file's created. And that's useful for things like PHP, where as PHP scripts might make a new file. And in the instance of our web directory here, I've already corrected this, but WordPress actually created this config file when we did the install, and it made it read-write by everybody because we haven't configured the UMask for the PHP user. And we really should correct that so that in future when PHP creates files, they're not globally readable. So what we'll do now is just to clean up, we'll remove that test file. Note it's write protected because of our permissions, but because we own the file, we can remove it anyway. So we'll just say yes. So that's gone now. So that's a bit of a primer on how the file permissions work for the file modes or the file mode bits. Hopefully I've explained this in a way that's clear enough to follow and understand. I know it can be a bit hard to grasp binary, especially if you've never worked in it before. It's pretty obscure to most people to work in anything but base 10. And as you work more with the computer, you'll start to learn about base 16, which is hexadecimal, or base 8, which is octal. There's all different bases we work in, but the primary ones are usually hexadecimal and binary. So if you can get familiar with that, not only will it help you with the file permissions, but it will help you with if you're doing a bit of programming later, or maybe you want to do a bit of electronics, doing some digital electronics. It's really handy to know binary counting, binary numbers, and how to turn bits on and off and so on. So if I've glazed over anything here or missed anything or explained something in a way that's a bit hard to understand, I apologize. This is a hard topic to sort of teach to someone that's never worked in this field before, but hopefully I've given you enough now to get the hang of this. So as always, have fun, don't stress yourself out with this, and I'll see you in the next video.